Hey guys, welcome to another Unity 5 tutorial today, and this is going to be the part 5 to the survival series, and this is going to be looking into a basic day-to-night cycle, or a time of day type of thing, where we're going to just sort of transition the directional light in the scene and make some changes. So I was going to go through the things that I've found, things that might make it easier for you, and the things that we're going to look at today. So there's a few assets on the asset store which actually are for free. And you can type in day-night cycle, and you can get the time of day system free by AC, and it's got very good reviews, and it has a lot of different features which include a day-to-night cycle. You can gradient the actual sky, there's stars, moonlight, night colour, and there's a few other systems on the store, but today I found something online from twic.net, and it's a simple way to do a sort of day-to-night cycle within Unity 5, and like I said, it's just about sort of rotating the directional light we've got and making up some values to sort of simulate this, and I'm going to go through that as we're going through this here. So I'll leave all the links in the description, and I'll let you know what assets that I've found. So we're going to go back into Unity today from the scene that we had. Previously, if you've used any assets or anything like that, depending on what asset you might have from the store, it's always best when you use the default skybox that comes with the Unity 5, and you can change that on the lighting tab, and if you don't have it, you can go window lighting, and you just want to use the sky default, which comes directly with Unity. And you'll see that within the scene, if I go out of 2D view and I sort of go back down to my FPS controller, and then I make sure I enable effects on the directional light that I've got, if I grab the rotation tool and I just have a look at my directional light here, I can rotate it round, and it will transition between sort of atmospheric times of day, so it will automatically adjust depending on where we're sort of aiming the directional light. So this is what we're going to transition today, really, with what we're trying to do. So with that in place, what we'll do is we'll create a new script, and we'll create a new C# script and call it time controller. And then what we'll do is we'll open up in MonoDeveloper or Visual Studio. And then what we can do is drop this curly bracket down here, get rid of the two sort of starting functions, and what we can start by writing is a public light sun, because we're going to want to reference our directional light we're using. Or you could actually write it like this, so you could write in square brackets serialized field, and we're just going to keep this to a private variable. And serialized field just lets us see this in the inspector, but keeping the variable private because we don't really need to be able to access it from other scripts. We can do the same here. We can go in square brackets serialized field, we can have another private variable and have this seconds in full day, which equals 120f. What we'll need is we need this to be a float value, and what we're saying here is that we're going to be looking for a particular thing. So we're going to be saying that how many seconds do we want in a day. You can adjust this in the inspector, which is fine, but we're going to say that we want 120 seconds in one day, and obviously, like I said, it's up to you to change that accordingly to your game. And then what we can do is we can add two more square brackets, and we can type in range open brackets 0,1, close up the brackets, and what this allows us to do is create a little slider in the inspector, so we can go from 0 to 1 in the inspector with a little sort of slider bar. We can do the same again and say serialized field and do a private float current time of day is equal to 0. I like to just keep it all on one line, usually just for the sake of ease, so I don't have to go over multiple lines. And what we can do is we can add one more private variable and call this a float, and have it as the time multiplier, which is equal to 1f. So this is going to be what we're sort of timesing the time by to make it sort of act, somewhat realistically. And we can have another private float, sun initial intensity with a semicolon. And then what we're going to do from here is we're going to write void start, 2 brackets, then 2 curly brackets below, and we're going to say that the sun initial intensity is equal to sun dot intensity. So we're just saying that whatever our sun is, so that will be our directional light that we're going to use, we're going to make sure that the intensity of that sun is based on whatever directional light we've given it, rather than having to give it a specific value. Then what we can do here is start by writing void update, 2 brackets, 2 curly brackets below, and we're going to sort of do the calculation for the actual time that we're going to use. We can create a variable, a function, in advance, which is called update sun, which we're going to use in a little while, so we can actually rotate the sun around based on what values we give it. We're going to use current time of day plus equals, and then in brackets time dot delta time divided by the seconds in a full day, and then we're going to times the whole thing by the time multiplier with a semicolon. So what we're literally saying here is we're saying that we're going to have the current time of day, which starts off at 0. We're going to, over time dot delta time is done every frame, and we're going to divide that value by the seconds that we've got in an actual day as we're going along, and then times it by the multiplier that we've got, so which is going to add a sort of realistic element, so it sort of counts up in a decent amount of seconds. And like I said, you can read on the website if you want more details. We can then write an if statement, and we say that if current time of day is ever then greater than or equal to 1, then we'll say that current time of day is equal to 0 again. Because what's this meaning is that if it ever goes above 1, which is our maximum value based on the range that we've given it up here, we're saying that we wanted to set it to 0, so it almost restarts the day again. Now, that's all well and good for just creating sort of that there's 120 seconds in a full day based on the sessions we've got in our game. But what we need to do now is we need to actually transform the directional light so we actually get some changes that we can see. So we can create a void which is called update sun, have 2 brackets and then 2 curly brackets below that. We're going to start by writing in this function, so we're going to say that sun dot transform dot local rotation equals quaternion dot annular, and then we want 2 brackets, opening the brackets, and then we say current time of day times by 360 f, and then outside the first bracket we want minus 90 comma 170 comma 0. And all this is doing is getting transforming the rotation of the local rotation of our sun. So we're not transforming it all the way around the world, we're just on its local axis, and we're rotating around based on the current time of day times by 360 based on 360 degrees that we can actually turn round. And based on what you can read in the actual post by the person who developed this, is that we have the minus 90 degrees just so that we can set the basis of the sunrise and where it would actually fall on the rotating of the X, Y and Z axes. And we have this one set to 170 for the actual horizon of where the height will be set, and then we have 0 because the Z axis doesn't actually do anything based on this. And then what we're going to write is a float, and in intensity multiplier, which is set equal to 1 to begin with. Then what we're going to do is have a few if statements which control based on where the actual position is of the directional light is how we're going to produce the actual fading of the light which the directional light is going to produce. So this controls the rotation, but if we don't actually control how it fades in and out based on the script, it'll never actually change its intensity, so it will actually be a full sun even when it's looking away, and can sometimes cause some issues. So you don't always need this that's going to come up, but it may well be beneficial. So we can say that if current time of day is less than or equal to 0.23 f, we want two large lines in, which is on your backslash key, which is just between Z and shift, and you can just hold shift and press the backslash and you'll create those, and it just means this or that. So if the time of, the current time of day is less than or equal to minus 0.23 f, or current time of day is greater than or equal to minus 0.75 f, what we're going to actually do is set the intensity multiplier equal to 0. So what this means, if the current time of day is ever less than or equal to 0.23, which is just before the sunrise, and the time of day is above this, which is just before sunset, we're going to set this multiplier to 0, because we're going to use it after to sort of fade the intensity of the directional light that we've. Then we can say else if current time of day is less than or equal to minus 0.25 f, we will then have two curly brackets below and say that the intensity multiplier equals mathf dot clamp not 1, which means that it'll clamp a value between 0 and 1. We'll have two opening brackets, and we'll say that current time of day minus 0.23 f, and then we will go outside of that bracket and say we will times, in brackets, 1 divided by 0.02 f, and close that up with a semicolon. So like I said, what it's going to do is it's going to check that if it's below 0.25, we're going to then set the intensity multiplier equal to a value between 0 and 1, but it's going to be the current time of day minus the value which we've given, which is just before sunrise, and we're going to time it by the value which is going to allow it to fade in. And we're going to do a similar thing with another else if statement, and we'll say that if current time of day is less than or equal to 0.73 f, then we're going to have two curly brackets below and say that intensity multiplier equals mathf dot clamp not 1 again, and then we're going to open up the brackets and say 1 minus, and open up two brackets this time, and then we're going to say current time of day minus 0.73 f. Outside of that brackets we'll say times by the 1 divided by 0.02 f again, and then we're going to have the three brackets afterwards and a semicolon. So what this is going to mean is if the time of day is ever greater than or equal to sort of getting to the actual sunset, we're going to set the multiplier based on this value, and then have something so we can allow it to fade the intensity out. And then what we're going to do just below here, we'll say that sun dot intensity equals sun initial intensity times by the intensity multiplier that we created above. So that every time we update the sun, we're going to just say that the sun intensity equals the sun intensity, which is the value, which is it when it was originally given, times by the intensity multiplier that we've given it based on the values that we've worked out based on the current time of day. So if we minimize this, and then what we can do is right click in the hierarchy, create new empty game object. It can be whatever. We can go back into the inspector, drag the time controller in here. Then we need to put a directional light into this, and you can see that the seconds in the day is 120 and the current time of day is 0. You know, we've got a little slider where we can change that. Then what we can do is press play, and you'll notice that when it starts off, you can see that because the time of day was 0 at the time, it wasn't actually doing anything, so it was technically simulating nighttime. And as we're moving up the actual values, we're getting towards the sunrise period, which is the 2325 value, and the sun will be rotating around on its local x-axis, and it will then increase the intensity of the sun back to its normal value, and it will rotate above the entire game scene and all the way above until it's above the terrain. And if I move towards the sun as it's getting towards the 0.73 and the 7.5 value, it's going to be rotating the sun away, decreasing the intensity of the entire sun, and we can see the directional light there. The intensity is currently 0 because it's rotating beneath us all the way until we get back to the point that we're looking for, which would be the 0.2 value again, which would be simulate the sunrise. And you can see that as the current time of day will be about to hit 1, it will reset the current time of day and almost do the rotation again, so we get the nighttime. Disregard the things that are going on in my scene because you can see some of the bushes and the environment isn't actually changing, because I'd need to sort of remove some of the baking that I'd done and reduce the ambient light, so then we could see a difference in some of the actual objects that we've got in the scene. And you can see as it hit the value again, we get back to the morning and we're rotating the directional light all the way back round, and you can see by the directional light we've got the intensity back to where it originally started, and we can use that over and over and over. And depending on what you want to do with your game, you can, decrease the temperatures based on what time of day it was, whether it was, sunrise, sunset, or, generally through the day. So that's just a basic way, and as I say, you can take a look at the website, take a look at the scripts that I used, but all in all, compared to probably a lot of things that you will find, it is fairly simple to just create using the sun. We're setting the time of day, we're setting the current time that we own based on time.delta time divided by the seconds that we've got and times in it by just a multiplier. We're checking to see if the current time of day ever hits 1, we'll reset it, which will be another day almost. Then we're updating the transform of the sun based on the day in a 360 degree motion. We're setting the horizon to 170 because that's the person who wrote the script found out that was good for their scene. You might want to adjust that accordingly. We create a simple intensity multiplier which will adjust the intensity of the overall sun based on whatever current time of day we have. So if we are less than 0.23 and greater than 0.75, we're not sunrise or sunset, so we're almost in the night, so intensity should be 0. But if we are between these two values, what we're going to do is we're going to do a fade, so we can bring the intensity back in as it gets to the sunrise, and fade the intensity back out when we get to a sunset. So hopefully, this helped you. You can have a look at stuff on the asset store, which might be more complex and might give you more of the things that you're looking for, and check out that website that I showed you originally, twink.net, for looking at a simple day to night cycle. So thanks very much for watching. Don't forget to like, comment and subscribe. Cheers.